Hello everyone, welcome back to our channel 10x Gen AI. In our previous video, we've learned about prompt engineering concept in detail. If you haven't watched it, click on the link appearing in the video, or you can also find the link in the description. As we have learned in one of the lectures, the language models have cut-off date to their knowledge, post which they cannot answer questions related to recent developments. We have also learned that ChatGPT cannot answer for your private data, unless it has been shared with the model during the conversation. If you are wondering how to overcome these limitations, welcome to Retrieval Augmented Generation, RAG. It is a framework used to augment or enhance the knowledge of a large language models, like ChatGPT, with external knowledge bases. This technique involves retrieving external data and passing it to a language model to generate responses. It can also provide up-to-date information about the world and domain-specific data to language models. RAG can be used to build industry-specific applications like question-answering systems. Data files are collected from various sources like web URLs, PDFs, or a company's internal data store, split them into smaller chunks, create embeddings for each chunk using an embedding model, and store them in a vector store. Based on the question asked by the user, it retrieves relevant documents from the vector store, combines those documents with the user's prompt, and then feed to any LLM like ChatGPT to produce the answer. Langchain is playing a crucial role in this pipeline. There are many integrations in Langchain framework that help us build this pipeline in few lines of code. Let's build an application using Retrieval Augmented Generation that enables us to chat with any website. So let's head to Jupyter Notebook. In this demo, we are going to create a pipeline that extracts Python documentation of Langchain from its website and answer questions related to the content. The entire pipeline is split into multiple sections: extraction, loading, splitting, storing, and retrieval. Let's break down each section of the code and understand how it works. First, we install the necessary libraries, including Langchain, OpenAI, ChromaDB, and Python.env. We also make sure to load our OpenAI API keys securely from a .env file. Next, we move on to the web scraping part of our project. We have a Python program stored in extract_urls.py file, in which we are going to use the crawl function to retrieve a list of URLs recursively from the given URL. These URLs will be the sources of information we want to analyze and extract content from. I will provide GitHub link of this program for your reference. This is the URL for Langchain's Python documentation. Let's call the crawl function with this URL. Since there are more than 1,000 web pages, for the sake of this demo, we are going to extract just 10 pages by passing max URLs parameter. I have already extracted all web pages and stored in a vector store, which I am going to show you as part of the Streamlit demo at the end of this video. Now, with the URLs collected, we proceed to load the content from these web pages using Web-Base Loader from the Langchain library. Let's instantiate the loader by passing the list of URLs we collected. Call the load method of the loader object, which scrapes the content from the URLs. The variable data now holds the loaded content. Let's print and check the content of any one loaded page. Now, we are in the splitting part of the pipeline. To get the embeddings of the data, we need to split the data into smaller chunks, using recursive character text splitter. Let's import that from Langchain.text_splitter. It takes a large text and splits into smaller chunks, based on the specified chunk size. It recursively tries to split by different characters until it finds one that works best. In this example, we are providing 1,000 characters as the chunk size and 100 characters as overlap between different chunks. You can modify this and play with different chunk sizes. Now, let's call the split documents method by passing the data. Print length of all splits variable, to see the total number of chunks. Let's enter the storing part of the pipeline, which involves creating a vector store for the split documents. Before that, we need to convert the data into text embeddings, for which, we use OpenAI embeddings and store them in a Chroma vector store. Let's import both of them from Langchain. Call from documents method of Chroma and pass the splits embedding function and specify the persist directory to store the embeddings. When we run this, Chroma processes all the splits and stores them as collection of vectors. Let's print and see the number of collections. Now, we enter the core of our pipeline, retrieval. Let's import chat OpenAI from Langchain.chat models, and create our LLM with GPT 3.5 turbo model, and temperature set as 0. Import retrieval QA, a type of chain used for question answering, from Langchain, and define the chain by calling from chain type method of it, to which we pass our LLM vector store as retriever, and we set return source documents as true, to see which documents are matched to the question asked. By default it fetches the top 4 matched documents from the vector store. Finally, we utilize the power of OpenAI's language model, specifically the GPT 3.5 turbo, for question answering. We pass our question, what is Langchain framework, to the model. Let's print the result. Here is the answer about Langchain framework, which is generated by our pipeline. If you remember, in the beginning of this video, we have seen that ChatGPT is not able to answer this question, as it is not trained on Langchain framework, by the time of its knowledge cutoff date. Additionally, we can access the source documents used for generating the answer, by printing result of source documents. Now let's head to the Streamlit chatbot, where we can ask more questions on the entire documentation of Langchain. This is the Streamlit application named Website Chatbot. I will share you the GitHub link for the code. Here, you can see 2 options, one for creating embeddings from scratch for any given website, which we have just done in the notebook. And the other is to load embeddings from a saved vector store. As mentioned, I already have created embeddings for the entire Langchain's documentation. So let's enter the directory to load the embeddings and press enter. Enter the OpenAI API key and press enter. You can see there are 9,239 collections present in the given vector store. Let's proceed to ask few questions about the framework. Our first question is, what are the different types of chains? Here is the answer on different chain types available in the framework. Below are the sources from which this answer is curated. Let's ask to explain sequential chain with example. Wonderful. It is able to give explanation with code example in greater detail. You can play with this bot by asking anything about Langchain framework and get instant answers. That's it for this video. In summary, we've understood what is retrieval augmented generation, and implemented the concept, by creating a website chatbot, using Langchain framework and OpenAI model. This versatile tool can be applied to a wide range of websites, making it a valuable addition to your AI toolkit. I hope you enjoyed this video. If you have any questions, feel free to drop a comment. Please like and share the video. And if you haven't already, please subscribe to get updated on more tech insights. Stay tuned, and keep exploring.